Baker's Log, Day 89. Things are looking pretty grim for Team 2A1, better known as the Cranberries. Preliminary reports suggest that Ford Dining Court has completely run out of crab rangoons, and our supply of Boiler Track's 150th year celebration ice cream is dwindling.
Oh man, not the boiler track.
I'm afraid so, Aus. Ben, Tyler, how's the aircraft sizing coming?
It's all set.
Excellent. Jeremy, is our CAD model finalized?
Good to go. Riley, could you walk us through the stakeholders again?
Sure. Our main stakeholders are obviously the survivors. They need to be extracted safely and quickly out of the danger zones. Our secondary stakeholders are the pilots who are operating and flying the aircraft.
Well, is that all?
No, rescue team members, pilots, and grounds crew who all service and fly the aircraft needed to be considered in the design process.
Sounds good, Riley. And how goes our requirements?
Prepare yourself, this is going to be good. The aircraft uses a skyhook to extract the survivors from dangerous and otherwise unlandable areas, and must have a length similar to a 737 in order to accommodate all the passengers and cargo we need to carry. In addition, the aircraft can be powered by different types of fuel like biofuel, and its maximum range is 2,000 miles.
Quite impressive, Riley. Keep going.
Right, so the aircraft can take off from the Purdue Airfield, which has a length of 2,000 meters and a maximum takeoff weight of about 200,000 pounds. Finally, the aircraft features a flexible bulkhead capable of expanding and contracting, which separates the bow passenger carrying cabin from the stern cargo bay to keep the cabin pressurized.
With all these top-notch requirements, we have to evaluate the risks. Tyler, what have you got for our risk assessment?
Well, our initial concept of implementing vertical takeoff systems on a large passenger aircraft involves several risks, including inadequate fuel availability, untrained pilots, and dangerous operating environments.
It's a pretty dangerous world we live in. Sounds like a lot of risks we need to mitigate. Good thing we have a great design. Ben, could you walk us through the design process?
Yes. So the design process for this amazing craft is very long and complicated. Our designs that we came up with each had their own benefits and issues that came around.
That's for sure. So what was the first design that we came up with?
So the very first design that we came up with that fit our requirements was an electric VTOL. So the way that this would work is that we would just have electric motors to spin propellers, much like an Osprey, and we would use some solar panels on the top to increase the range.
Were there any major issues with that design?
Actually, yes. In order to operate in VTOL mode, we would need the engines to generate enough thrust that is greater than the weight of the craft. With conventional electric motors available now, we ran into the issue of not being able to generate enough thrust to keep the aircraft from falling out of the sky. And another issue is that the batteries needed to power this craft are very big and very heavy.
I like the idea of renewable energy sources. What else did we consider for that?
We did look into nuclear power for engines. Problem was that these engines are under-researched and very hazardous. The amount of radiation shielding that would be needed adds too much weight to the craft. Also, if we want to rescue survivors, we wouldn't be able to land near them because of how much radiation the engines would emit. That's why we felt that using a biofuel made from all this corn would be the best idea.
So what sort of things did we find were the most realistic and practical?
We initially brought our design down to two options. One would have a heavily modified stock 737 combo. We would rip out the engines that are on the craft and move them to the end of the wings to allocate for engines to rotate in a vertical mode. We would also replace the back end of the aircraft with an operating cargo ramp. This would let us implement the skyhook into our craft and allow for us to drop supplies down to survivors in safe zones.
So what about the other option?
This was the most interesting of the two. What we came up with was something very similar to what Tyler was describing. We would take a 737 fuselage, rip off the wings, and set two new sets of wings in a tandem wing configuration. This would mean that we'd be able to use shorter wings and also 4 engines, and we would be able to operate this in VTOL mode using the engines and therefore creating less strain for them.
Any notables with this one that let us lean more towards one or the other?
So the issue with the 737 Frankenplane was that the plane would operate in VTOL mode with very high bending moments on the wings because of how we had the wings placed. And also, during this, we would also have the issue of only having 2, so it might be underpowered for VTOL mode.
Great. So what did we decide? Jeremy, can you walk us through our final design?
So our final design that we end up with It's a tandem design consisting of the fuselage of Boeing 737 Combi but converted to fit our needs and requirements.
So what exactly did we have to change?
Well, the first thing we had to do was remove the horizontal stabilizer and fit in a secondary wing in its place. We did this because of our VTOL desire, and it leads me into the next big change to the plan. We removed the two stock 737 engines and fit 4 Pratt & Whitney PW4094 variant engine in its place on the wingtips. Those engines are gimbaled to provide VTOL capabilities and thrust vectoring.
Wow, that's pretty crazy. Fills the VTOL requirement, carries plenty of cargo and passengers, and is absolutely badass.
Sure is, Haas. Well, this whole ordeal has been a learning experience. Aside from learning how to kill zombies, we learned a lot about designing aircraft.
That's for sure.
The 251 course taught us how to identify stakeholders' needs and requirements. We were also able to take this information and shape it into an actual observable design. Moreover, we learned the overly sophisticated code that helped us size the aircraft.
That was a pain in the rear.
Indeed. All in all, this has been a valuable experience and has helped us communicate our ideas better. We worked out our problems efficiently, and we all went home knowing the thing was done.
Oh god, the zombies are at the door! Quick, get to the roof!
Gentlemen, our time has come to leave. Purdue has been overrun with zombies, and the situation has become dire. The fastest way out of here is to evacuate with the Skyhook system. It's been a great run and real pleasure to work with all of you. None of this would have been even remotely possible without the wonderful knowledge given to us in our 251 class.
I can't believe it has come to this.
Our home for the last 2 years has finally been enveloped with these walkers. Riley, Jeremy, put some harnesses on these guys.
Alright, here we go.
Wait, Ben, where's your harness?
We only have 3 left. I want you all to get out of here, and maybe I'll see you on the other side.
No way. Take my hook and save yourself instead.
No can do, Haas. Get out of Purdue and try to find civilization elsewhere in the world without zombies. Maybe even go to find a place to live with more than one hill on the entire campus.
Well, thanks, Chief.
I couldn't have done it without you all. Get him out of here.
Baker, are you sure that this Skyhook is a safe enough system? Have you checked the needs and requirements of our stakeholders?
Don't you trust our work? We have updated the stakeholders 3 times since we started this project.
Got me there.
Did I mention that I'm afraid of heights?
Yeah, me too.
Oh god, here comes the plane. Ah!